Hi, in this video we're going to do some examples of calculating equilibrium. Now if you remember from the previous video, this is our formula. And here let's do some examples. Question 1 says 3F2 gas plus 2Fe solid makes 2FeF3 2FeF3s. Now the product will be 2FeF3. So, alright, now we're not giving any concentration, molarity, now we're not giving any molarity, moles, or liters. So we just need to write the formula down. So over here, product will be FeF3 to raise to the second power, concentration of FeF3 raised to the second power divided by concentration of 2 raised to the third power plus concentration of Fe raised to the second power. But no, we can only use aqueous and gas. So this is incorrect. And the correct answer will be 1, since there's FeF3, the product side doesn't have any gas, so we're just going to use 1. And over here, Fe is a solid, so we're not going to use that, and we're only going to use F2 squared. So this is the formula that you're going to use to solve for the equilibrium. And now the same thing goes for if the reactant doesn't have any gases in there, you'll just write 1 over whatever the products are. And we're going to show that in your second example, which is 2KClO3 solid, we're not going to care about that, makes 2KClS solid, we're not going to care about that, plus 3O2 gas. So in the product side, all we have is 3O2, so we're going to use concentration of O2 raised to the third power divided by 1, which is the same thing because there is no gas reactants in the gas reactants is the reactant side. Okay, next, the equilibrium concentration for the reaction below were found to be bracket AgNO3 equals 0.0070 molarity and CuNO3 2 equal 0.48 m at a certain temperature. Find the equilibrium constant K for the reaction. And the equation we're given here is 2AgNO3 aqueous plus Cu solid makes CuNO3 2 aqueous plus 2Ag solid. Now let's write the reaction and products real quick. So products is the concentration of CuNO3 2 raised to the first power divided by, we're not gonna care about these because they're solids, divided by the AgNO3 raised to the second power because it's aqueous. And now we're given the information that we need. 0.007. We're given 0.007 and 0.48. So this will be 0.007 for Ag. So 0.0070 raised to the second power time, and on the top will be 0.48. 0.48. The final answer should give you something around 9,800. But when you're writing equilibrium points, we do not use the rule of 3. We will generally use only 2 numbers. So in this case, 9,800 is only 2 significant figures, so that is correct. So in equilibrium, we'll only generally run to 2 significant figures. Now, lastly, we're going to take a look at ice chart. And ice is very similar to the RBCA chart that we did a while ago. So let me first write the reaction. The reaction is CH4 gas plus 2O2 gas makes CO2 gas plus 2H2O gas. So first we're going to write down everything. CH4, O2, CO2, and H2O. Then we're going to write initial, change, and equilibrium. So first, let's write the expression for the equilibrium constant, right? The equilibrium constant will be product, which is CO2 times H2O raised to the second power because there's 2 moles, divided by reactants, which is CH4 times O2 squared. Now, it is giving you some information. Initially, there are 0.5, 0.5, the concentration is 0.5, and then the concentration for O2 is 0.52. And then we learned from the PV10 chart that in the beginning, the products will always be 0. Now let's choose. Now another part of information is that it told you the change is plus 0.1. So in the end, it added 0.1 moles, and that is a crucial piece of information that we're going to use to find everything else. So first, moles to moles, this is plus 1 mole of CO2 over 1 mole of CO2, 0.1. And then for every 1 mole of CO2, there are 2 moles of H2O. So over here, we're going to write plus 2 over 1 times 0.1. Same thing for goes here. Every 2 moles of O2, there's 1 mole of CO2, 2 over 1, times our same constant, 0.1, 0.1, 0.1. We'll use that same number for all 4 of them. And finally, CH4. For every 1 mole of CH4, there's 1 mole of CO2. So it will be 0.1 as well. And if you remember, reactants are minuses and products are pluses. So 0.5 minus 0.4 equilibrium. 0.5 minus 0.2 will be 0.3. 0 plus 0.1 is 0.1, and 0 plus 0.2 will be 0.2. Now we just plug all of these values into our formula, which should get us 0.1 times 0.2 squared divided by 0.4. 0.4 times 0.3 squared, which should equal to 0.11. And that is our equilibrium for this reaction. And just to be more specific, this is Kc. And when Kc is equal to a number less than 1, that means the reactants are favored. Thank you for watching.